All right, today we're going to be focusing on how to rewrite exponential expressions. This one's kind of hard to see, so I'm going to make it a little bit bigger. We have 3 to the power of 5x plus 3 times 27 to the power of x. And we're going to try to rewrite it as, put equal, so as 3 to the power of f of x. So ultimately, it looks like what we're looking for is like, what does f of x have to be in order for these to be equal? All right. So when we're doing this, we're going to be dealing with 3 different properties. Okay. So let's review the 3 properties real quick. So please make sure you have these in your journals. The first property is called the product property. So here's a quick little review of the product property. All right. If I have any base to the power of m times the same base to the power of n, I'm allowed to take those exponents and simply add them together. That's called the product property. So do you guys see how this right here, the product property has already been used. So watch how I separate it. All right. So right here, technically, if I wanted to, now we don't have to do this for this particular problem, but if I'm just showing you a quick little example of how you could separate it. This is 3 to the power of 5x, right, times 3 to the power of 3. So if I wanted to break it down, these mean the same thing. I just want to make sure you guys know that these mean the exact same thing. Now, we don't have to do that on this problem, but I just want to make sure you know that you could. There's another property called the quotient property. And the quotient property states that if you have the same base, what are you allowed to do with these exponents? You're allowed to subtract them. So you're allowed to subtract, if they have the same base, you're allowed to subtract the exponents. And last but not least, we have what's called the power property. So make sure you guys have the power property written down in your journal. And the power property states that if you have a base raised to a certain power and you have another power on the outside of the parentheses, that is the only time you're allowed to take these exponents and multiply them together. So you have to be able to know that the 3 different properties, the product, the quotient, and the power. So right here, I just showed you how to break this down. We're going to have to do that for another problem. I'm just going to go ahead and erase it right now. We have to, in order for this to work, we have to get everything to the same base. So here is our base. That's our base. That's a base 3. This is not the same base. What's that base? 27. But this base is a 3. So what we're going to have to do is there's one of these that we have to convert. We got to convert one of these so that we can get it to the same base. Which one do you think we need to convert? The 27. Yeah, we got to convert the 27. So somehow we got to get a 27 into a base 3. Now this is where it's very, very helpful if you know certain powers. So you don't have to write these down in your journal, but I want you to understand 3 to the power of 1 is 3. 3 squared is 9, and 3 cubed is 27. So does everybody see how 3 cubed and 27, they are equivalent to each other? So instead of a 27, what am I going to rewrite it as? 3 to the power of 3. So you guys need to see that this and this, these are the same. Okay? Now, what's already up there? An x. So it's this 3 cubed times x right here to the power. That these mean the same thing. Then we have what? 3 to the power of 5x plus 3. Now there's a little dot right here. Dot multiplication. Dot products. Okay? Equals 3 to the power of f of x. Now, of these 3 properties, which property do you think we're going to use? Are we going to use the product property, the quotient property, or the power property? Which one do you think would best Yeah, the product property. Now check this out. The product property says we're allowed to do what with the exponents? Take them and do what? Add them together. So we're going to take this, and we're going to add it to this to get this. So what is 5x plus 3x? What's that a total of? 8x. And what's already sitting there? A what? A plus 3? And that's my answer. 8x plus 3. Because what was I looking for? I was looking for what f of x was equal to. Well, I couldn't add the exponents together till I had the same base. So I had to convert everything to the same base. And I took 5x and added 3x and got 8x. And then there was a plus 3 at the end. So right now, in the Khan Academy, I'm going to write 8x plus 3. That's it. Okay? All right. Here we go. Here's your next problem. We're going to work on this together. All right? Right now, first thing I'm going to do is I'm going to write it a little bit bigger. All right? That says 1/3, and that's raised to the power of -9, and there's an x, and somehow I got to equal a to the power of x. So I have 4 different answer choices. All right? So I'm going to highlight something real quick. I'm going to highlight all of this right there. Okay, I'm going to highlight all of that. And I'm going to highlight this right here. Okay. And there's only one thing A could be in order for these expressions to be equivalent. A can only be one thing. So I'm going to pause real quick and talk to my class about that, and you can think about it on your own if you're watching this. All right, so I'm going to use a box maybe and see if this will make sense. So literally, I got to take this right here, which I can clearly see is right here, and that's what I would have to put in for A right there in order for these to be equivalent expressions. So that's why I'm choosing answer choice C. Okay? That's the only one that would work. Now I'm going to go back and restart this because we need to see more examples. 2 examples is just not good enough. All right? So here we go. If you would please write this one down. This one's a little bit trickier. It's not going to be too bad, but it is a little bit trickier. So we have 3 to the power of x minus 3 to the power of x minus 2 equals a to the times 3 to the power of x. And I'm going to highlight literally what we need to find. We need to find what a is in this expression. Now, what I'd like you to do is I want you just simply to bring down that 3 to the power of x. All right? And I want you to put minus. Now, this is the part where you have to know one of the properties. So right here, I'm going to highlight this. Okay? And what we're going to do is I want you guys to quickly think about the product property. If I have b to the power of m plus n, that would separate to b to the power of m times b to the power of n. But if I had b to the power of m minus n, that would separate to b to the power of m times b to the power of negative n. So what do you think 3 to the power of x minus 2 would separate to? 3 to the power of x times 3 to the power of negative 2. Do you see how if these had the same base, I could add them and put them together up here? Now I'm simply doing what? I'm separating it into what? 2 different little terms. So make sure you please write that down. And that all equals a times 3 to the power of x. Okay, so now we got to go over some quick little algebra, all right? Here we go. If I have a times b plus a, if I have a times b plus a, does anybody see a common factor in this little tiny binomial right here? What's our common factor of a, b, and an a? What do you think? A, you're right. So I could factor out an A. Now, if I factor out an A, what am I still left with? I'm still left with a B, but if I factor out an A here, I'm left with the number 1. So I want you to scan this right here. Scan this. Does anybody see any common factors? And I'm going to go ahead and highlight it in magenta here. See any common factors in this? Close, not just a 3, but 3 to the power of. Is there a 3 to the power of x right there? Yes. Is there a 3 to the power of x right there? Yes. So here's what I need you to do. Okay? This is the tricky part, okay? You have to know how to factor out 3 to the power of x out of this expression. So if I factor out 3 to the power of x, all I'm left with is the number 1. Minus. If I factor out 3 to the power of x here, what do I have left that I'm going to drop down and put right here? 3 to the power of what? Negative 2. And that's all equal to a times 3 to the power of x. Now I'm just going to let you guys know we're pretty much done. You're like, so what the heck did we just do? Here's what we did. We rewrote the expression. We separated this into 2 terms using what's called the product property. So we did that. Then we factored out 3 to the power of x, and here's what I got to let you know. Whatever this is right in here, guys, whatever that is, that's a. Because we got 3 to the power of x, so whatever this ends up becoming is our value for a. So just go to the calculator. All right. Now, if you were to do it by hand, it would be 1 minus. Now, 3 to the power of negative 2 is 1 over 9. All right. And the answer is going to be 8/9. But if you go to the calculator, just type in 1 minus 3 to the power of negative 2. And you'll get a whole bunch of 8s, but you got to hit the math button and press enter twice, and you get 8/9. So what am I saying my answer is? I'm saying my answer for A is 8/9. Of all the problems, I think this is the most difficult out of the problems. But 8 divided by 9. All right? And I got it right. All right. Here we go. Let's do a couple more problems. Then I will help you individually, all right? So what do we have? We have 5/6 to the power of x, and we want it to equal a to the power of negative 8x, all right? So I'm going to do a better job of writing that 5/6. Here we go. 5/6 to the power of x. All right, guys, so here's what we got to do. Once you write that down, I want you to highlight literally the only things that they have in common. What's the only thing that matches between these two expressions? What's the only thing they have in common? The x here and the what? The x right there. So what am I going to have to do somehow? I have to get this side somehow equal to this side. All right? So what do you guys think that my a value right over here, what do you think it has to be if you had to match it up? What do you think? Well, you're going to have the power will have to equal negative 1/8, but what is the a value? Like, what are we going to have to match it up? It's got to be what? 5/6, right? So we got to have what? We got to have a 5/6, right? But remember, so I'm just going to drop it down. So it's got to have a 5/6. All right? But what's sitting up here? A negative what? A negative 8. But I don't want it to become a negative 8. What do I want it to become? I want it to become a, what number is right there? It's a what? It's a 1. So how do I get negative 8 to a 1? What would I have to multiply that by to get it to a 1? Well, you got to multiply it by another negative, right? And what's the reciprocal of 8 over 1? Well, 1 over 8. So what I want you to understand is I got to have this and this in order for them to match. Okay? So I'm going to put an X here. I'm going to put an X here. And I'm only going to highlight the stuff that I need. So here's the stuff that I already have. I already got that. Okay? And they gave us what? They gave us a -8. But what did I need to plug in? I needed to plug in this. And what else did I need to plug in? This right here in order for these expressions to become equivalent. So which answer do you think I'm going to choose? A, B, C, or D? Correct. I'm going to choose A. Because that's what A would have to be in order for these expressions to become equivalent. All right. All right. Last one, guys. Last one. 1 over 49, close parentheses, we got an X, times 1 over 7 in parentheses to the power of 6x plus 11, and we're trying to get it equivalent to 1 over 7 to the power of f of x. Ultimately, what I'm trying to find is what the heck is f of x. So please write this down nice and neat. All right, guys, the only way this is going to work is I have to find a base that all of these work together. So step number one, I'll put over here. You got to have the same base. Okay? That's step one. You got to have the same base. Well, listen, 1 over 7 and 1 over, these already match, right? So what do I have to convert? I got to convert the 1 over 49 to what? 1 over 7. Well, how do I get 1 over 49 equivalent to 1 over 7? Does anybody know what 7 squared is equal to? Well, like 7 times 7? 49, right? Well, what do you think 1 over 7 parentheses squared would equal? 1 over 49. Okay? So watch this. 1 over 49 is equal to 1 over 7 being squared. Now, what variable is already there? There's a what? So I want you, these are the same, guys. These are the same expressions. They're, well, not same. They're equivalent expressions, but I had to convert it to 1 over 7. Yes. And we got 1 over 7 to the power of 6x plus 11 equals 1 over 7 to the power of f of x. Now, check it out. Do all the bases, is every single base match now? These all match. They're all the what? They're all the same. If they're the same, then what am I allowed to do with this exponent and this exponent using what's called the product property? What am I allowed to do? Add them. So my final answer is 8x plus 11. Where the heck am I getting 8x plus 11? Because 2 plus 6 is 8, and there's already an 11, so I know that's my answer. So really, what's the only thing I had to do on this? Change it from a what? 1 over 49 to 1 over 7 being squared, and then add them together, and that's it. So it's 8x plus 11. So I'm going to type it in, 8x plus 11, and I'm trusting the process. The numbers are changing, but the process remains the same. All right? All right, you guys go ahead and work individually. I'll help you with, I'm going to do one quick problem. My students are going to be working in class. This is another easy one. We got 29 to the power of x over 2, and we're trying to get it to equal to a to the power of x. So right now, these, we got an x, but that's what, being divided by a 2. So what would a have to be? We know a would have to be a 29, okay? But right now, here's the problem. That's a what? X over 2. So what cancels out? What cancels out in x over 2? Something that's being squared. All right? So right now, I want you guys to, well, hold on. We got it. That's what gets what canceled out. But we got to make this a what? A half. 29 to the power of 1/2. So I'm going to highlight what we have to keep the same here. I'm going to put this right here. Has to match up with this right here. There's our x's, but we have to make this a 1. Okay? So we have a 29 to the power of 1/2. That's what would have to be plugged in order for this to be true. So if I plug in a 29 to the power of 1/2 of x, that's the same as saying 29 to the power of x over 2. These are the same. These are equivalent expressions. So I'm going to choose this guy right here. And that's it. Good luck.